Okay, let's discuss about the limiting question. And the question says that evaluate limit x tends to 1, limit x n tends to infinity, 1 plus sine pi x to the power n minus 1 divided by 1 plus sine pi x to the power n plus 1. Now, usually in this kind of limit calculation, we tend to find out the limiting value by confirming the validity of RHL and LHL, that is the right hand limit and the left hand limit. So as you see that here x is tending to 1, okay, and n is tending to infinity. So for n there is no RHL because n is tending to infinity, so there is nothing to the right of infinity, so only one-sided limit for n tends to infinity. But for x tends to 1, we need to consider the RHL and LHL, because to the right of 1 and to the left of 1 we need to see that where this function is tending. So for that, let's first start with the suppose RHL calculation. So let's plan for the RHL, okay, at x equal to 1 we are planning. So for calculating RHL at x equal to 1, so we can easily see that x is tending to 1 plus, that is x is tending to 1 from the right side of 1, that is x is slightly more than 1. So naturally you can see that pi x will be an angle which will be slightly more than pi, so we can write it as pi plus. And as you see that pi plus means it's an angle which is slightly in the slightly more than pi, so it is actually in the third quadrant, right? Anything more than 180 degrees in the third quadrant, and since it is in the third quadrant, so sine pi x can be claimed to be a negative quantity which is slightly less than 0. Okay, so we can easily say that sine pi x will be slightly less than 0 because the angle is in the third quadrant. So we can say that 1 plus sine pi x, this quantity will become slightly less than 1, okay, because sine pi x is 0 minus, slightly less than 0. So if I add 1, then this quantity will be slightly less than 1. Now something which is slightly less than 1, and if I multiply that quantity infinite times, so 1 plus sine pi x to the power n, now this n is tending to infinity, so 1 plus sine pi x to the power infinity, we can easily say that will be tending to 1 minus to the power infinity. So it is something less than 1, something slightly less than 1 to the power infinity, and something slightly less than 1 is multiplied infinite number of times, then we can easily claim that we are going to get lesser and lesser value, and that quantity will be actually tending to 0. So the RHL answer is going to be 0 for this function, okay. I mean for this particular part, okay, beg your pardon, for this 1 plus sine pi x to the power n part, we can say that the limiting value is going to be 0. So we can say that this whole thing is going to 0, so this quantity is going to 0 and this quantity is going to 0. So what is happening to this whole function? This whole function is tending to, we can easily say that this whole function is tending to 0 minus 1 divided by 0 plus 1, which is nothing but minus 1. Okay, so RHL of this limit is going to be minus 1. And side by side, if I analyze the LHL in this case, so let's plan for LHL at x equal to 1. So when we are planning for LHL at x equal to 1, so we can easily say that x is tending to 1 but from the left hand side, so we used to write it as x tends to 1 minus, slightly less than 1. So pi x will be tending to pi minus, okay, slightly less than pi. So sine pi x, you can guess that sine pi x will be a quantity which is slightly more than 0, because you can see that the pi x is an angle which is less than pi, slightly less than pi, so it will be in the second quadrant, less than 180 second quadrant. So in the second quadrant, sine will be very well within the positive region. So sine pi x will tend to 0 plus, so naturally 1 plus sine pi x, so that will be slightly more than 1, so we can write it as 1 plus. And as the quantity is slightly more than 1, and if I multiply this kind of quantity infinite times, so 1 plus sine pi x to the power infinity, that is 1 plus something slightly more than 1 to the power infinity, and that quantity will become gradually very large, and that quantity will tend to infinity. Okay, so when we are calculating the RHL here for this limiting value, LHL for this limiting value. So we can see that LHL is going to be equal to, for LHL we can see that this whole quantity is going to be tending to infinity, so it is becoming infinity, very large. So compared to this infinite quantity, this 1 in the numerator and denominator will become negligibly small. So with respect to this huge quantity, we can easily neglect these two values in the numerator and denominator, and we can easily write down the LHL to be 1 plus sine pi x to the power n, which is a very large quantity, divided by 1 plus sine pi x to the power n, that is equivalent large quantity, neglecting that 1 and minus 1 and 1, okay, because those are negligible. So ultimately these two cancels out and it is giving us an LHL value to be 1. Okay, so we can see that the LHL is minus 1 but the RHL is LHL is 1 but the RHL is minus 1. So finally we can claim that the limiting value does not exist. Okay, so final answer is going to be limit does not exist, because as you know that the left hand tendency and the right hand tendencies are not equal, so we cannot consider the limit to be existing.